Hello, everyone. Let's keep going. So, anybody had a chance to figure out the mystery of why the submission didn't work, or any thoughts about that last week? What we were trying in the beginning?
Nope. I'm baffled by it. I have no idea, sorry.
Yeah, no, that continues to baffle me. Why the submission with those things didn't work, whereas every other submission seems to work.
Maybe
Is
worthwhile
it,
posting it on the forum and seeing if someone has an answer. That was very interesting.
Yeah, I haven't posted. That's a good thought. Maybe I should post in discussion saying, hey, I kind of write this based on Steve's notebook, and for some reason it just doesn't score. Because
Yeah.
that's really weird why that should be the case.
Yeah.
Right? Because, yeah, no theory at all and completely lost.
I
By the way,
suppose you could
on
try.
that,
I was going
go
to
ahead.
say you could try, like one set of values worked and then your set of values didn't. I suppose you could
Yeah.
try the notebook that works and just replace them one at a time to see which one causes the problem.
Oh, you mean each class?
Yeah, so like your submission has got 6 entries in the list.
Right.
So yeah, with the one that works, you could replace them one at a time until you find which one breaks it.
The thing is, it needs each of them. The sum of all of those needs to add up to one, right, at all times. That's the requirement.
Mm.
So you can't replace one without fiddling with the others, or
Yeah.
at least they have to go together. I mean, some has to be, and we confirmed. That's the puzzling part to me, right? We confirmed online when we were submitting that both of them add up to 1.0. Your values that
Yeah.
you had originally submitted and the new ones. We did remember np.sum and convert the list
Yep.
to numpy array, and still added up to one. So it's like I said, maybe I'll just post in the discussion. But by the way, on that note, the one thing I did want to comment is I finally got around to trying what I'd been talking about, which is instead of taking, and I have only done this for spectrogram, I still intend to do it for EGs, but instead of taking the grouping the spectrograms or taking the center of spectrograms, quote unquote center, just that is converting all of the spectrogram. I mean, there is a single spectrogram which has all of these slices, and they take the central slice and then average per spectrogram. I instead tried to do what I think we discussed previously, which is create a spectrogram per slice and then use all of them, so that I have now 106,000 whatever 800 spectrograms that I done run training on. The problem with that, just FYI, is, I mean, of course, I didn't go through the hassle of downloading it and running it on Colab and stuff, but the problem is it takes a long time, given the size of the data set in this case. Remember that if you didn't do it, and if you did, I don't know, a spectrogram or EEGs, but it reduces to about 11,000 or 10,000 or something if you group them. And I didn't group them, but to make a long story short, if you just train it on that, you have to make your batch size much bigger to fit into the 8-9 hour limit, and it doesn't end up giving you as good of a results anyway. It's like I just got the score I submitted last night. It's about 0.52 or something like that. The 128 batch size, and it on or it fits within 8 hours. Just so if you were inclined to try that, that doesn't seem to help. I'll of course try it on EEGs as well, just to see whether EEG data is somehow different. I just wanted to.
Had your model finished training? Did it?
Yes,
Did it?
it did. It did.
Yeah.
Yeah, it finished in 8 hours, but like I
Right.
said, I had to increase the batch size to 128. Even 64, I felt would push me outside the 9-hour limit. Then I did the math, and I ran one epoch, and that told me how long it would take, and I reduced the number of epochs to, it kind of is interesting because the at least for a ResNet, which would imply that any of the other ones too, it overfits very quickly. Like 2 epochs in, the validation loss begins to increase. And, the training loss keeps going down, but the validation loss increases. And the CV score, I could tell that it wasn't going to be as good as even 0.46, 0.47, or, 0.4 something, because even my out of fold CV scores were pretty bad. That's an interesting data point. I haven't quite figured out why that would be the case, that when you provide more data to it, it fails to train. Maybe you need to, augment it and such to prevent the overfitting. But of course, I didn't try any of that. Not even a simple horizontal flip or anything. I just tried the plain vanilla stuff. And that gives worse results, just in case you're inclined to try and it takes a long time to train. So, why
I'm guessing you'll have to drill around with your learning rates and stuff too, right? If you've bumped up your batch size to like 128, I'm just curious, like maybe there are other things that need to go in, like along with augmentation and stuff.
Yeah. No, that's a good thought. Like I said, augmentation, learning rate, weight decay. I didn't tweak any of those. I just wanted to kind of see whether if
Right.
it would work, and
Yeah, good baseline. Now you can see if you can improve from there by doing things.
Right. So if you can see my screen now?
Mm-hmm.
Yeah. So this is my score for all of them. By all, I mean
Okay, all of the okay.
every single one of the stuff. So I think this is all the standard thing. But in fact, interestingly, the guy creates the arrays for every single, or actually he does something slightly different, but I just split and save for every single one of them. And then, of course, this is inference. Yeah, of course, for the splitting, I still split polls based on expert consensus and grouping on patient ID. But instead of this thing he did where, where he groups it by the spectrum ID and takes the first one, which essentially means that he only picks up the first of all these numpys that he generates. But I don't do that. I don't group it, and I leave my training to give me each of the numpires, and because he groups it by label ID, and by the way, the label ID is unique for every single EG or every single spec. In fact, that's the reason I believe that they have a label ID. So the label is unique to every single image. So when you do this, he's actually generating all of the numpys for every single slice. But by doing the train here and grouping it, I mean, I renamed it, but he just continues to call it train. But by grouping it with the spectrogram ID and then taking the first instance, thereby he collapses all of the spectrogram slices to the very first slice. Kind of.
Who
And
is
I
it does
avoided
this?
that, and I left it.
Was this somebody's code that you took?
Yeah, this is that Tawara guy.
So does
not
he save?
the Yusu.
Does he save
Sorry, go ahead.
100,000 NumPy arrays then?
Yes, he does. This thing is, in fact, where's that? Here, this thing, he does save 100,000. But it takes only about 8 minutes to do it. But it takes a lot longer in the EEGs, by the way. So he does it in line. I mean, you could potentially do this offline, save it as a data set in import. Does it in line. It takes only about 8 minutes or so. And you can see, for me, it took about 16 minutes.
What is the is there an issue with the label ID here when you're using it in the case with all the spectrograms?
What do you mean by that?
I'm wondering, like, since you said each label ID is unique for each spectrogram, right? So this is not grouping or anything by that. This is just
it is grouping it, right? Because remember that every array he labels it by the label ID, which means that every split of the spectrogram is given its own NumPy array.
Oh, okay, grouping like that. Okay, fine. Okay, that makes sense now. Okay. Yeah, I misunderstood
I mean,
something.
it's not grouping, it's just every label ID is unique.
Okay.
So every slice of the spectrogram is put into its own NumPy array.
Yeah. Okay.
Right?
Yeah, I think
whereas, and he just, so to Steve's point, he generates all of the data. But then in his standard notebook, which I modified, which is why I pointed to this thing I commented out. So he says, I use the first spectrogram, and he does that by, where he does the train group by, instead of renaming it, he just calls that train. And he converts all of the spectrograms and groups them and then puts it in train, which means his train now is just the very first spectrogram ID.
So yeah, that's what I'm saying.
And then he uses that to train.
Right. Going back to what Steve was talking about previously about kind of maybe the weighting of the data is kind of changing. Maybe that could be another reason why the score is going low.
Yeah. Although I don't know whether, because we don't know the weighting of the test data or the public or private test data, right? So in a sense, I don't know whether the argument as to
no, it's like you're augmenting. If you let's consider multiple rows as augmentation, right? That's what the closest analogy for us is. It's kind of like you're taking certain rows of the data and augmenting, and you're taking the other set and not augmenting. So there is kind of like an inherent bias, at least at first look, that is happening over there. Like you're doing some operations on certain rows, whereas you're not doing those same operations on the other rows. So I'm saying like a bias.
Why do you say that? Sorry.
Because certain rows are just single ones, right? Like for certain patient IDs, you just have one thing. So whether you take first or you don't take first, or your strategy, That is not changing. There are only certain of them, in which case, when you take first, you're actually reducing the number of data points for that patient ID, versus when you don't take first, you're taking like whatever, 10,
Yeah, but
15.
that argues for the remember that the training is worse when I use all of or the
Yeah, that's
models
what
I
I'm
get are
saying.
worse when I use one,
Correct. So that's what I'm saying.
right?
Like, so when you're training with all your things, in for
Right.
the patient IDs with single rows, that is not changing, right? Like the bias is that you're augmenting only half, let's say, I'm just using half here, like augmenting half of your data, whereas you're not augmenting half of your data. It's a very, at a very high level is what I'm just saying, like the differences that are potentially there.
Yeah, if you were to
But
print out the
anyway,
percentage of each group between when you take the first one and when you have every single row, yeah, like other vote tends to have many more rows, doesn't it, than any other one?
yeah,
Whereas if you
in this
only
case,
took
that's not the
if you only
case.
took the first instance, it's probably not as extreme the difference.
Yeah, in fact, it's the other way, Steve. I found that, see here, when you see the things, they're all about roughly the same, right?
Yep.
Across the folds. Whereas I can show you, so if you, this is the, these are the numbers, right? So you can see they're all in the 3000s. And then there's a little bit of a, this is closer to 5000, but 4800. And again, if you see here, they're all kind of equal. Now, let me show you the, you see this? You
Yep.
see this number versus that number. See this number versus that number. Consistently higher.
Yep.
Almost a factor of 2. Compare this to this, just as a first pass. By the way, another tidbit, we play around with this a whole lot. Another tidbit I found is that I do the same exact thing with tenfold versus fivefold, and the ResNet 34D. I just showed you the baseline thing, which is this guy here, which is using not just per row, but grouping it. So it's per spectrogram, I call it. That actually the score improves between fivefold and tenfold by about 0.02, at least for me. It doesn't seem to happen for EEGs. I haven't confirmed that for EEGs, but for the spectrogram-based stuff, a tenfold thing, seems to be a little bit better. Actually, I need to qualify that. Not for the base ResNet, but there's another guy who uses, he does an ensemble, but I said, okay, let me try without ensembling. He uses EfficientNet V2, and there are various versions, small, medium, large. By the way, don't bother trying medium and large on Kaggle because the medium and large models are too big. So it just runs out of memory instantaneously. But at least the small seems to work. ENet V2S, and I can post one I'm referring to. But so you can see here I have that in US. And I tried this, and this particular model between fivefold and tenfold, that's about a 0.02 difference. I thought was interesting.
Yeah, I mean, I don't know if that's a significant stat to go by, like if that difference is significant, but
Yeah.
like if you go tenfold or higher, I mean, 3, 4, 5 higher, basically in that way, you're training on more data, right, per se, for each fold.
Yeah, yeah.
So your model ends up seeing a little more, and yeah, I sometimes it helps, sometimes yeah, I don't know.
Yeah,
You're
I
expecting.
don't know whether you can convey. I agree with you. I mean, I don't know that you know that I would rely on it, but I was just curious to find out, does it make a difference? Because
Hmm.
I've seen some people or instance where tenfold is done, and I just wanted to figure out, does tenfold versus fivefold really cause a difference? If you'd asked me, I would have said maybe not, but and the answer is kind of also falls in the question mark category for me, because some models like the base ResNet 34D model, it does not.
Hmm.
Tenfold and fivefold gives the same result. But then for this particular model, that is about a 0.02 difference. So I mean, that's why I just wanted to call out that, hey, it kind of seems to, your mileage may vary kind of answer depending on the model as well.
Right.
Interesting.
Anyone with new ideas or anything new that they saw? I just caught up with the last video, and yeah, it sucks that the brain code stuff takes so long. Otherwise, that seemed like a very interesting approach that Steve was taking.
Yeah, so I've given up on that and I've gone now.
Mhm.
There's like a notebook I mentioned last week. It's about just taking the EEGs themselves, not converting them to spectrograms,
Mm.
and then it applies like a 1D CNN on each channel.
Okay.
With it, I get like a public leaderboard of 0.5.
Okay.
But that's only using eight of the channels, because like
Oh,
Chris Diot, he produced like a NumPy data set of the 8 channels, which is what he uses to make his spectrograms. So
mm.
so there's 12 more channels I can add in.
Mm.
So but I found there's other notebooks which have like a lot of sort of EEG processing to clean it up, which does the same as like the sort of MNE thing.
Mm.
Yeah, so like using that, I think like Chris Diot, it's in his notebook about the wavelet thing. Although
Mm.
he has it turned off, so he's not using it.
Mm.
And I found like another notebook about cleaning EEGs. So yeah, I was going to stick with the 8 channels and try cleaning them up and see, does it improve the performance? And if it does, then I was going to
Mm-hmm.
increase the number of channels.
Okay.
Can you put the link to the notebook which has that cleaning thingy?
Yeah, I'll I'll find it amongst my tabs. I'll put it on shortly.
Yeah, Steve, what's the
Thank you.
difference between the 8 channel one and the different channel one that you alluded to earlier?
Well, the EEGs themselves have 20 channels in them,
Okay.
but Chris Diot, he's only interested in the 8 channels to make the spectrograms. Like his banana picture.
Mm-hmm.
So he only uses 8 of the channels to make the spectrograms to make his spectrograms match with the Kaggle spectrograms. So like he's just ignoring the 12 other channels. And like the notebook I was talking about last week, like the 1D CNN, it uses Chris Diot's NumPy data set. So yeah, it's only using 8 channels. But there's no reason why you can't use all 20.
Mm-hmm.
The other thought I had as the question for you folks is, the spectrograms, I mean, there's obviously the spectrogram and the duration is different. So that's one point. But at the same time, we convert the spectrogram to a fixed size image, 256 by 256 or resize to 512 by 512. So the question I had is there any reason, I haven't tried it, I just was thinking about doing it, and I was wondering whether people had what your folks' comments on it are, is why not, once you've converted the EEGs to spectrograms, why not train a network on spectrograms and then continue to train the same thing on the EEGs? I think Chris does something like that eventually when he has final public notebook that he posted, I believe. Does that make sense? I mean, ultimately, it's a spectrum. You've converted even the EEGs to spectrograms, and then they also become similar images. So you could train the network on the spectrograms and then save the weights and then just load those same weights and continue training them on the EEG, and then use that network trained on both spectrograms and EEGs, because by the time you convert EEGs to images or to spectrograms, they're also spectrograms, and you also size them to be the same shape, right? So is there what are the, I can think of one, but are there any big reasons why that's a stupid thing to do or not a smart thing to do?
I don't know if I understand this completely, but aren't they like two different networks? One is looking at images if you're looking at anything spectrogram based. And if you're going EEG, which is waveform, wouldn't that be like a time series?
No, both you're converting to NumPy arrays, right? Both have been converted to spectrogram NumPy arrays by the time. I mean, spectrogram also is in fact, going through the MEL process of EEG conversion, you converted that also to spectrograms, right? At that point, they are equal. Equal meaning I don't mean to say they are identical, but the format and the thing is the same.
No, but I'm saying, like, isn't your training data like one of them? So let's say we have EEG, which is a waveform. You take that EEG, you convert it to a spectrogram. Now you train your model on this spectrograms that you get. So you're looking at a version or some transformation of the EEG, and you're building a model of that spectrogram. Now, if you show it a different form of data, which is your EEG, then you're kind of hurting your model rather than helping it, right?
No, I'm not saying. I'm saying I'm saying same form, right? You have converted the EEG, or at least in the thing that I'm thinking of. Basically, EEGs have also been converted. There's the same method, the banana, whatever that he was referring to.
Are we talking about
converts it to a spectrogram?
Both the spectrograms, Kaggle provided spectrograms, and EEG. Yeah, that I think that is what. Chris is training on both of them. I think he uses both.
So that's what I was saying. Is there any reason why that would not be a good thing to do? Is just train the network on the spectrograms and then train the network on the EEG converted spectrograms.
Are you saying, is there a difference between that or training on the whole thing together?
I'm seeing people ensembling the two outputs. I'm saying instead of ensembling, just train the network on both and then use that to infer rather than ensembling the two inferences.
That's been a while.
I think what Chris Diod does, but do you see the difference?
Yeah, I see what you're saying, but this has been a while. I haven't really checked in the last 10 days or so what Chris has changed, but from what I remember, he was doing all the spectrograms, because I think somewhere there's a note where he says Kaggle provided spectrograms and my spectrograms, and then he says he's updated the notebooks to use those. But I think it makes sense to use all of the data rather than just do pieces of it in different places, or then kind of
but interestingly, the score, at least that I've seen, of many people, except one guy, the score of like let's take the most common public notebooks of using ResNet 34D when they train it on spectrograms, and let's just use that. The score is in the 0.4 range, and barring Christie or many of while the conversion from EG to spectrogram is identical with some differences. Chris doesn't resize, the other guys do resize. But setting that aside for a minute, the scores using the EGs are in fact just the EGs, purely the EGs, not ensembling the two, but just the EGs. Scores are higher than the 0.4x kind of figure. And I was just wondering whether if you did just train on both the spectrograms from the spectrograms and the spectrograms from the EG, train the same network, and then infer using that, whether the score would be better than the ensembling approach.
Yeah, I think his whole goal of using only the 8 things and trying to get the spectrogram to look as the EEG spectrograms to look as close to Kaggle spectrograms was to use the whole thing so that he trained. Otherwise, you kind of see like different data, right? Like your transformations don't match up, then you're kind of mixing data up there. But yeah, I think, that makes more sense. What you're saying is like you'd rather train 3 models on all the data and then ensemble the results than trying to do half of the Kaggle spectrograms and then train on the model, like just the EEG spectrograms and then try to ensemble, I guess.
Yeah. That's what I was thinking. Okay. I know Chris was already doing that, so I thought that's probably a smarter approach, but I just hadn't tried it.
Talking about the score difference, there is something I can't remember, but at least last one I was reading, there are some of these, what is that? Normalization stuff that were kind of built in when he created the data set. So I think if you're doing that again, don't quote me, I don't remember this exactly, but there was some problem, I don't know. His data set already had some things which were done to it. So in general convention, you would end up doing that again, which was not meant to be done. I'm saying means and standard deviations and things like that, but I don't know if it's exactly.
He does. That's done
some
as part of the conversion to the. You have to be careful with that. You don't end up doing it multiple times.
Yeah. So I don't know if that is creating trouble and stuff like that. Yeah.
I haven't gotten to that level yet. I just wanted to think through, because one of the things I wanted to try was this, using per row, or of course I'm going to complete the exercise for EDs also, and whether they yield a different result than spectrograms, but at least for spectrograms, don't waste your time, because I tell you that doesn't.
If you're up for it, I would say, instead of jumping into using all the spectrograms, use maybe like how the current one uses only the first one. Maybe iteratively try just using like the first and the last one. And that you can see whether the score improves from what happened with
even though actually he doesn't use, if you see, if I recall correctly, I could be wrong, I'm talking from memory, but the better approach per se would be not using, he just uses the label for the first spectrogram. Right? Because he just picks the first spectrogram, and instead of using every label ID, he just uses the name of the spectrogram to get the NumPy array. So he'll get, the label ID corresponding to it will be the very first one. What would be actually a better thing to do if you're going down first and last and that kind of thing would be probably taking the mid 300 slice rather than even just the middle and the last order. Like by that I mean, like you have a zero. Again, I go back because I have the numbers in my head of the very first spectrogram as like uh, a 40 is the max offset, so it goes from 0 to 640, and which means because there is every 2 seconds, so it's from 0 to 320. So that means you would probably want to take the middle, like forget 10 from each and then take the 100.
Right. So
So
I think that would perform better than
correct.
using all
Yeah.
of them.
So if I were to do anything beyond that, then I would do that kind of
Right.
approach, which is
Right.
take a spectrogram which takes the middle chunk.
Yeah.
And that's what, by the way, I don't know whether you recall, Rachel, but in fact, the thing that I was trying to figure out in one of my experiments was, if you did this middle kind of stuff,
Mm-hmm.
and I forget now whether I was doing it for EGs or for uh, spectrogram. I have to go back and look at it, but I was definitely doing the math. I was trying to figure out whether you are missing out. I think I did it for EGs because I was doing it, if I recall, in actual seconds. That's 50 seconds, which means 50 times 200 is 10,000. But the point is that I was trying to figure out whether are you leaving any interesting chunks out if you just
Right.
hit the middle.
Mm-hmm.
And it turns out that yes, you are leaving out certain interesting chunks if you take the middle, not for spectrograms, but for EEGs, because there
Yeah.
are some EEGs where, the thing is, I believe, heavily skewed towards like the latter part of offsets, large offsets.
And I'm guessing that for any of the patients with a single EEG, that does not make a difference, right? Because both those would yield the same thing.
Yeah, yeah, yeah.
Okay, so
Say
it's only
single, then it
right,
doesn't matter.
right,
It's only when there are a lot of slices
lot of slices as well.
and also, like I said, that the slices are heavily oriented towards like large offsets, because the
Yeah,
large offsets, what they tend to do is they shift the end very far. So if you take the middle, you're kind of not getting the relevant parts of the latter offset.
okay, okay. Mm.
And there are about 3,000 of those cases in the
Mm.
data. That's
Okay,
what I was able to determine.
okay.
Yeah, this week I actually tried taking like the median value.
Mm.
Yeah, because of the fact, like as you say, like if you take the minimum offset and the maximum offset, and then you take the middle bit, it may be that you're sort of taking a slice of the EEG or the spectrogram that wasn't actually voted upon. It could like actually be like a load of rubbish.
Mm.
Yeah, so like between the minimum and the maximum, I was taking like the middle actual offset value because like it's an offset that's actually been voted on.
Right, okay.
But it may be, I'm still not decided. I think it gave me slightly better results.
Mm.
Yeah, I
But
would
yeah,
anticipate that that's probably correct, Steve, based on what I've done, because it showed me that there were about 3,000 or 3,500 cases where taking the middle would end up, by taking the middle, you're losing, like you say, the voted upon values.
yeah. Yeah, because if you look at someone like the EEGs, some bits of them, there's no signal at all. Yeah, like some of the EEGs just have like rubbish areas within them.
Mm.
Mm.
I'm curious to see how those votings change for a single patient on a single EEG with those multiple sub-IDs, how drastic the differences are. But yeah, I don't know how to kind of visualize it other than looking at each patient by patient, because I
Yeah,
feel
that's the other
Yeah,
thing I was thinking of
there are,
doing. Yeah, like I noticed that some of the votes are identical across like an EEG. Every
Hmm.
single row has exactly the same votes.
Okay.
Whereas, yeah, like some of them, the votes do change across a single EEG. So I was thinking of like trying to break it down. So it's like if multiple adjacent rows have the same votes, then I would combine that into
Right.
a
Okay.
single image and take the middle one. So like if you've got like 5 rows together, that would give me one image and one set of votes. But yeah,
Okay.
like I could still get multiple windows out of a single EEG if the votes change.
Okay. I see. Oh,
But it might be a
yeah.
test of my pandas skills
Yeah,
to
exactly. Need to be.
to
Yeah,
implement that.
that's. I was thinking about it too. Like, man, that would be a interesting stunt to pull out in pandas, and it'd be interesting code to figure that out.
Or
Yeah,
just ask ChatGPT with a small data set. That's what I've been doing.
yeah, that's what I do for everything nowadays.
Yeah. Yeah. Yeah, I was thinking actually talking on those lines, I was thinking maybe I haven't looked at what the distribution is of how these sub IDs, the votings change. But if I don't know how many of them change, but maybe I can remove just those rows out and then try it, like noise or pull those out and then see how it performs on.
But here is, but here's my question, right? Like, here's the question on that.
Mm-hmm.
I mean, I haven't thought at all deeply about this, but I have two conflicting feelings, and I haven't yet dived into those to see which of my feelings is correct or wrong. But should it matter if we don't, meaning if we just are interested in whether, given the test data does not have this condition, right? Meaning because there's a single patient, single EEG, single spectrogram, right? So
Right.
there isn't this situation that the model faces in the test data. You're given an EEG, given a spectrogram, given a single patient predict. So should we even care about? That's why I thought that the per row or whatever is closest to the test condition that the network will see, right? Because you really don't care whether multiple of the votes of or multiple segments in your EEG are relevant. Because in the test situation, when your network faces something, all it faces is, I have 50 seconds, I have 10 minutes, just predict.
No, but only one part of that is true, right? If you were given only just one EEG ID per patient ID, then yes, I agree with you. Like if you're just taking a
But that's
instead
what
of
happens in the test case. In the
no,
test case, that
exactly.
is the case.
But when you're training on all the rows, you're not actually simulating that, right? You have the same patient with multiple sections of that same EEG ID. So for me, it's like you're telling it, look at this image, and you're giving it different labels, or you're giving it same labels and showing it different images. So I don't know. In my head, I feel like that's the difference uh, that is happening with respect to training versus test there. What you're saying, like that's what, like one part of it, I agree with it. Like it's just one row you're looking at, you're caring about only one row, and the test is also just one row. So you're in that sense, yes, they're the same. But your one row in the training is actually it could have the same label, and you're showing it two different images, like I said, or two different images with the same label, right?
No, I didn't get two different
You could
images,
have the
but
same voting, but you're showing it like two different images, right? Or two different EEG readings. Because
yes, because two
yeah,
different slices is what you're talking
exactly,
about, right?
exactly, exactly.
Yeah, but
So
two different.
that is kind of making it harder for the model, right?
Correct.
So that's what I'm saying. Like if you in the ideal case scenario, if you had just one per
No,
EEG.
no, but that harder is good, right? Because basically it needs to recognize that two images, two different images, but they lead to the same conclusion. It's like you said before, it's just like an augmentation, right? It's saying this view of a person's head and that view of a person's head is the same head, is the same person, sorry.
Yeah, that's what that part I'm still not convinced. Like I haven't looked at how those like what is changing in those EEGs, or is there something that I've not been able to
The
visually
time,
see
I
that?
mean,
No,
now
no,
the
time,
time
yes, but
to
I'm saying
people.
like how the readings are changing. Like so
Yeah,
there is
yeah,
something in the reading that has changed, whereas there is still
right.
something in the reading which is making people vote the same way. So that
Yeah.
signal, at least visually, I'm not able to kind of figure out and see like, is that what
Oh,
is
yeah,
happening?
yeah, yeah.
Or what is going on there? Like for me to visually, or at least at
Yeah,
an intuitive level to understand there.
yeah.
And
No,
that's where
that
I feel
in
there's a
fact,
difference.
yeah, but that is almost you're now getting into the kind of, I mean, that's the danger of this kind of work is you're getting into what, as I went through the course that Steve pointed to, I mean, you begin to realize that, the expertise that the folks have,
Right.
it makes them pay attention to things that, you know, so if you really need to, what I was, I guess the shorter version of my comment is to say, in order for you to understand what differences causes people to give it the same vote or change their vote, you would need to understand kind of like become more expert on
Right.
reading the charts, right?
Yeah. It's,
Which, that's what is
yeah.
scary about these things is we don't do that. We just kind of treat it as a mathematical kind of problem to solve. So,
Yeah, so that's where I don't know. I feel like that's the difference between if you use all the rows and yeah, kind of say that yeah, you're just going to get one row in the test. Or there is some other better way to pick out the best row for an EEG rather than yeah, this first, last, or I don't know, the median thing that Steve was
yeah, the
talking
median,
about.
those are the various different
Right. So
um, approaches. And by the way, there is still what you said, which may very well be true, which is, because I've um, increased the batch size and things, there may need to be compensatory adjustments made, and that's the reason that it's not learning well, right? So,
yeah. I mean, you
um,
could just try
and
dropping your learning rate and see what happens. Like, already you're saying at 2 epochs you're kind of overfitting. So maybe train slower and then see if it kind of moves into a better spot. That
yeah,
could
yeah.
be.
But, I think the whole thing is, like I said, the constraint is 8, 9 hours, and I just was lazy to download it and put it in
Yeah.
Colab and kind of upload all that and then set it up
Yeah.
and run. But otherwise, you could just kind of leave it at 32 and run it, but it would just take forever.
Yeah.
Or even, I think the other thing is once you add on Colab, you can also use a more powerful thing like
Actually,
100. So
to make this simpler in your case, you should just be using patients who have multiple rows and just take a subset of that and then train on first for those multiple patients. I mean, those patients with multiple EEGs, and then do all EEGs, right? That is a much smaller, faster experiment, which will kind of give you an idea of what is this multiple rows actually yielding to, if that makes sense. Right? Because nothing is really changing with people with one rows. That remains the same. It's
yeah, in fact, I don't. That obviously is a simpler thing to figure out is how many patients are there with just a single row and how many are there with multiple rows.
right. And then just use those with multiple rows and do the
I would
same thing.
assume that the number of patients with single rows is fairly small, but I don't know.
Oh, I'm also not. Yeah, and then after that, yeah, obviously based on that, just take a subset and then train only the first and with all the rows. Like those, that'll be the final experiment that you would have. It'd be interesting to see how that changes. Yeah, I've spent so much time trying to figure out and how to make my experimenting faster. But I couldn't do any experiment which took less than 5 minutes for me. Like how much over I tried dropping the data and like using a reasonable model to get consistent scores. So
You want your experiment to be 5 minutes long?
I know. I mean, I was following Jeremy's approach, right, where you kind of drop it down.
Drop all
And,
the data.
sorry?
If you drop all the data.
No, that's not with consistent results. Yeah. Uh, so yeah,
You can
that's
run it in your head the fastest
yeah. I mean,
rather
like
than
whatever,
running it.
whatever is that's again a judgment call, or I don't know. Like with practice, you learn that how, or there is some reasonable way where like okay, fine, you have to. There is no escaping 5 minutes or 10 minutes that you have to wait for this to run before you kind of launch off your 8 hours or 9 hour experiments to kind of make decisions, right? So for me, I don't know. I was able to do that with like a ResNet. I can't remember what was it, 20 something, and then yeah, and 20% or 30% of the data, and at least like on 5 rounds, I was able to kind of get back the same-ish numbers. So I've been trying to use that and see other results. God knows if that'll actually match with the leaderboard moments, but yeah.
You see, Srinivas, the notebook you were showing us, where it saved like each separate window as its own NumPy array. What does it do? How does it actually create the data set? Does it load all those NumPy arrays back in all into memory, or does it start?
No, in fact,
Does it
that's
read the files when it's
it
doing
just
it?
reads the files,
Yeah,
which
because
is
like file reading is
kind
really
of,
slow.
I know, but it just because you're just reading. I show you. I was also surprised that he did it that way, but it doesn't seem to hurt him. I mean, I was thinking I'll improve it to save it and then into a data set and do it, which is what I think a couple of, including Chris illustrated, right? But if I were to share what he does out, is notebook. This is the reference notebook that I'm using or from. But if you see what he does, stores it here, and
Yeah, because like Christie
he
processed it all into a single NumPy array and saved the
right.
whole
And you
NumPy
could
array
do that too,
and
by
then
the
loaded
way.
that back
Yeah,
in, because like then you're only loading one file and it's all loaded into memory. Whereas if your
correct.
data set is still going off opening files every time you want to get the NumPy or spectrogram,
Yeah.
it's going to be very slow.
So, yeah, but interestingly, that's what this guy does, because you see, he just creates and
Yeah, but it was
stores.
more in the data set. What does he do to get things back? So in your data set, when you ask for an item, does he go and load that? Yeah, here.
So
Get item.
here, get item, self-image paths, right?
Yeah,
The
there's an
image path
image
itself,
upload.
image
Oh
path
yeah.
index, and then
Yeah, so
empty
he's
load
loading
image
everything.
path. Yeah, and then processing it, and which is what he does. And it is, I mean, it probably takes longer than it should, but add in, I just wanted to kind of see whether my results matched his and stuff with things I was playing around. So I haven't taught in this, but like you say, in fact, when I tried for EGs, because in fact, I was surprised that he was doing it in line like this rather than, because the other thing you could do is just process the spectrograms, store them away, and then just don't even do this processing part here, right? You could just be loading it off of the data set instead of processing it here. And that's another speed up, because you're spending 8 minutes or whatever of your notebook just processing it, which is not needed. You can just shove that aside and load it. He doesn't do that, but maybe because it takes 8 minutes, whereas if you do it for the EGs, it takes a lot longer. and obviously a lot longer for the EGs be converted into spectrograms. When you group them by EGs, and then of course, when you do it per EG, which I finished running last night, that I didn't time, or I'd have to go check how long that took. But even the base EEG conversion takes about, when you group it by EEG, it takes about 2 hours or something. So I'm assuming if you did it per every slice, then it probably is going to take you like 4 to 8 hours, 4 to 6 hours. Yeah, and then I spent a lot of time, I think, as I spoke last week, convincing myself that, what he does with this scale div loss, logits val, blah, 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 is exactly the same as what the other guy does with a much simpler 4 lines of code. And like you showed last week, like you shared, or, Chris does it with some scale div thing, codes, I think. But eventually all of them turn out to be the same. But the one nice thing I liked about this setup compared to the other guy, the UCC guy, is the fact that he also does this, but you can kind of see the transformation stuff. You can kind of in more transforms, if you will. Yeah, the thing, I just wanted to set up the whole infrastructure. I still have to do the EEG part, but then I still think, the things you're trying, Steve, of this EEG conversion or EEG cleanup, and because I still feel that the individual, the single notebook before you ensemble, there's opportunities to get that to be better. And that's where, by the way, where am I still sharing or not?
No.
Share because I wanted to show. Is the last month coming up on the Optiverse thing?
Yeah, there's 1 month to go. I'm not sure what date it finishes.
So if you look at, people have been obviously
Oh, there's a new one.
There's a 0.371, which
Yeah, I just took that 0.38 one. But
this
I'll
one.
have to get, I'll have to go to 0.37.
Yeah, I saw the blend.
So there's all kinds of blending and all that, right? But then the thing I was interested, as I said, I'm still, and I think that aligns with Steve, your effort to kind of figure out, what's the cleanup process in EG and stuff. And part of my interest was in, as I said, the spectrogram scores, trying to lower just that and trying to just lower the EG scores before figuring out, I'm interested in ensembling, but we'll get to that as the last step, right? But in that process, this guy has the lowest score. Of course, it's also an ensemble, but if you set that aside for a minute, his score is the lowest for just using spectrograms. I haven't seen anybody else, including Chris or whatever, to just get a 0.42 on spectrograms.
What do you mean?
That's why
I thought Chris Diot got.
Yeah, I also thought it was a point. Yeah.
0.43 I thought was his lowest. I might be off, but
all right. I got a 0.42 with Chris Diot's notebook by training my own data. Oh yeah, I used the EfficientNet B1 and it gave me a 0.42.
Oh, I see. Okay. So now again, that's really good if you could get it with just your own and a single, because in this case he does use three different models. And that's where I found the models he was using, and he did a tenfold split. The model is this thing, and then there is a medium version and a large version. And obviously he is trained offline, because if you see, he has like a bunch of them, but you can't train any, like, unless you did all kinds of.
And it looks like you bumped the image size too, right? If you scroll down, say something like 600 by 800.
Yeah, he's played around with it, although he does say, this is just inference, by the way, although he does say in the comments that he has, the score he got, the 0.42 is only with the 512 by 512. And he does, in this notebook, because of this variation, he includes everything, but he eventually ends up using only three, the notebook, if you see, and all of the three eventually end up using, if you trace the code, just the 512 by 512.
I see.
But he has trained the models, meaning the SM and L models, and shoved them in here in these various model thingies or model files. But obviously he's taking them offline, because you can't even begin to train M and L Kaggle unless you played a lot of tricks.
Actually, if you go back to where the notebooks were, there was an interesting notebook.
Sorry.
That multimodal 1D plus 2D EEG with a 0.41 score. I haven't seen that.
I think that's the guy who's 1D CNN I took.
Oh,
but it
this is
was
1D CNN one? Okay, cool. I should
I
look at.
think that was him.
Is the one that you're talking about?
No, I think it's the same guy.
Okay.
But I think this is a newer version. He's now moved on to 2D EEG.
See a 1D CNN ResNet in the block diagram below there. Okay.
Does he use PyTorch Lightning in this?
But, yeah.
Yeah, so I think I've taken his earlier notebook just for the 1D CNN. It looks like he's now combined it with the 2D bit. What score did he get with that, sorry?
0.41 it looks like there.
0.41.
Well, that's pretty impressive.
Yeah, this is an interesting notebook. I'd like to see this one.
Yeah.
So he just uses spectrograms or EEGs?
Both, I think, right? If you look at the block diagram, he's pulling in the raw signals from there. He's using the spectrograms that is passing through a 2D CNN. The EEGs are like 1D CNN, and then he's combining them up. This is nice. Okay.
Yeah.
So he does this EEG using a 1D CNN, spectrogram using a 2D CNN, and then does a contrastive loss on that. I don't know how he is, if he
Yeah, I don't know how that is set
and then
up.
he's just combining the two somehow, I guess. Slightly different way of ensembling, I guess.
It's a training together, right? Not so much of ensembling as such. He's training both the models. It's a multimodal approach in that.
Sorry, is this just his submission notebook? Does he have a link to his training notebook at the top?
Previous notebook.
Yeah.
So this is the one that you were talking about, Steve?
Yeah. He had a link there to his training notebook as well. Yeah, so that's the one. That's the one I've been using. Yep.
Okay. and then
Yes.
here is the
Okay.
training for
Okay.
Yep. All right. I'll have to grab a copy of that.
Yeah, this one looks really interesting.
Yeah.
the
Oh, yeah.
is the 1D thing you were talking about, right?
Yeah, so I
The
took this
approach.
notebook and, as I say, like I've made my own. He just uses Chris Diott's NumPy data set in his 1D thing. Yeah, so I've made my own. So as I can like, yeah, so he
So
uses
did
that.
you follow Chris Deer's approach to generate this data set?
Well, as far as I'm aware, he just, yeah, I don't think he mentions how he makes that data set. That data set is just taking the EEGs, and yeah, taking the middle slice of each EEG, and like just saving it with 8 channels. Yeah, so I've just done something similar, but kept all 20 channels, and like yeah, done the median offset value as opposed to the middle of the thing.
I see.
When you said 20 channels, are you using the heart rate stuff also in that, Steve, or is that out?
I have the heart rate in,
Okay.
but
Not
at the
using.
minute I haven't used it yet. I've only
Okay.
trained
Okay.
on the 8 channels just to like try and compare to see does
Ah,
the median value give me any benefit over the middle value.
makes sense. Okay.
And yeah, like as I say, I wanted to like apply some of like all of the EEG processing stuff to like clean up the signals before to see if that helps me before I go up to 20 channels.
Okay. Okay. Oh.
That's the point actually. Yeah, like a lot of the notebooks they've got code or whatever for applying low pass and high pass filters on the EEGs and applying that wavelet stuff to clean up the signals, but I don't know if that applies equally to the heart rate signal. Does it need to have? It's maybe different. I don't know.
Probably, yeah. I
Might
wonder.
just drop. Might just drop that one to start.
Yeah.
Actually, this guy seems to even also get 0.4.
Yeah. What has he changed?
Right, with just an efficient T0.
Training on GPU, rough touch inference loop.
By the way, here's one which uses
What
GPU with PyTorch.
What DDP is he using though? Is he just splitting the data into? That's the question.
Don't know that, but
Da.
it would be an interesting notebook
Yeah.
to go through, I think.
Yeah, like PyTorch Lightning gives you the ability to run on multiple GPUs, whereas if you were doing it in in PyTorch by itself, it's a faff.
Okay.
in this case, he seems to be doing both, right? Not, but
Okay, Lightning module. Okay.
oh, look at that. Even
Right.
kind of what I was talking about on steroids would be just like almost concatenating the two chunks of data, right? Like two
Yeah.
images, phytol by phytol, and just smush them together. This thing. So each of them is by one, and then he converts it to a XXX.
The dimension, yeah. Where is his training loop? Probably further down, I think. Like he's defined the class there, so. Ah, okay. Where is the multi-GPU stuff happening? I don't see that here. Or does PyTorch Lightning automatically pick if you have multiple?
PyTorch Lightning dot trainer, so you'd have to.
Yeah, I think PyTorch Lightning picks it automatically.
Automatically picks up if you have two GPUs. Okay. Oh, this is a better approach then. Okay. Oh, this is interesting.
Slightly low.
Yeah, that's pretty low. I think the lowest I've had in anything I've trained was like 0.69.
Yeah. 6.7 is what I've gotten.
Oh, you see it says there efficient net B2. Is that just his print statement? Sorry, yeah.
Yeah, his print.
Yeah. Here he says efficient net B2.
Yeah.
What the heck is he actually using? Because I do that too. Sometimes I'm too lazy to change the comment. To go figure out what is the actual model he's using.
I think he was using the TIM library, so if you just search for TIM, you should be able to find that. No, I saw Ross Whiteman's name there, so.
Martin, what?
I think WIG, if you just search for WIG, let's see if that shows up. Ah, there you go. Yeah, he's using B0 itself. Yeah. Yeah.
It's interesting. Why does he just download the weight rather than he's just using a path for some checkpointed thing?
Does
Why would he
Kaggle
do that?
have that? Wait, where is he pointing to? Inputs, HMS.
Pointing to weights here, right? See
sorry.
this efficient at B0, HMS efficient at B2. That
So he's
maybe because
uploaded that as a
he
data
has
set, right?
that. Yeah, here.
Yeah.
This
No.
is
Yeah.
trained. So he's trained it offline then?
No, he has it below there, right? Efficient at B0, the last one.
So he loads this and then creates
Yeah.
this. Okay.
I think he stored it in the same folder. Cool.
That's an interesting one because it's, well, not a single spectrogram per se, right? Because he has used both ED and spectrogram data and gets about 0.4. That's about the best that I've been able to do with ensembling. But with a lot of model ensembles, whereas he does it with a single model, right? So that's the cool part. Whereas I've gotten to it by ensembling models on spec 10 models on, whereas it is an ensemble still because it's 5. I'm assuming it's 5 models, but 5 models is a lot better than 10 or 20.
Yeah, but his five models are just cross-fold in that sense, right? Like, in
Right,
terms of the
right.
conventional ensemble we're talking of, yeah.
Yeah, those are
I
only
was
his
also
five folds,
thinking,
aren't they?
sorry?
Those are just his five folds.
Yeah, right.
Yeah.
So I was also
Yeah, when I
thinking,
talk about models, I also was talking about just, I mean, they're all kind of, they're only two models, but ensembled over five folds in both cases. So about 15 total four with them as well, but with two or three, whereas here he's just doing it with one.
yeah.
So, and it seems it's neater in the sense of just running it on multiple TPUs and stuff too.
Yeah, I was also thinking, I don't know, I couldn't make out what others were doing and trying to climb up the leaderboard. I was wondering, yeah, if it was my next approach was going to be just trying to build a different bunch of models and then just trying to ensemble or blend those together. But this multimodal thing that we just found seems very interesting. So I think, yeah, spend some time looking at that. Not sure.
Yeah, if nothing else, you can learn how to
Yeah,
combine
exactly.
these with this.
This is super interesting. Yeah, this was the approach I was waiting someone to put out. I'm glad someone did. So yeah, let's see how we can combine those two pieces of data.
And this also uses Python Lightning, just like.
Oh yeah, that's true. And is it just using one GP or is this guy also using two T4s? Wait, I thought that information was on top there, but Grace is not there. Okay. Oh, this is just.
Or,
Oh no, this is training, right? Yeah, I don't know.
or reading notebook.
Yeah, it doesn't look like.
Yes.
Okay.
So this is the submission.
Ah, P100.
Submission, we're just using one inference, but relevant training is 6 seconds. That seems weird unless it was just
Yeah, what is
glitch.
going on there?
Yeah, that doesn't make any sense.
Yeah. Okay. Not sure if you guys saw there's a new home credit stability competition which has also
Yeah,
started.
yeah,
I saw that and
yeah.
Oh, I
from
saw that, yeah.
my recent obsession with tabular data, I was very curious to see. There's a ton of data on that.
Oh yeah, yeah. Like I have enough problems getting all of this data in my head. Like
Yeah.
I'm going to stay. By the way, I did see one post somewhere since you said tabular that there's apparently some. I mean, there have been multiple, but I saw somebody post. I'll see whether I can get a link and post in our lack of a foundational model for tabular data.
Oh, okay.
I don't know. I mean, I've seen some recent claims to that effect, but I just saw somebody post something on another channel I'm on. Whether I
Interesting.
can dig
Okay.
that up and whether it's in, with zero shot predictions and that kind of stuff.
Okay.
Seems
Interesting.
really very advanced, given how much of a struggle tabular data is for deep
Yeah.
learning and stuff. So I'm curious whether it's
Yeah. Yeah, just
a
having a
couple of different things to try. I guess this multimodal is one, then what
yeah.
this guy is doing is another, right? Like
I
repetition
just
at
tried
zero.
I just tried there taking the multimodal guys thing
Uh-huh.
and his submission one, it's all, if you look at the input of it, if you
Oh,
look at the
private
input
stuff.
tab, yes,
Oh.
it's
Oh
all
man,
private data sets. Yes, you can't save that one.
Okay.
His, yeah, I don't know. I hate people that do that,
Yeah.
publish public notebooks and then you can't
With
actually
private
run
data
them.
sets. Yeah.
yeah, what's the
And
point?
yeah, so I just tried taking his training one. It's failed as well.
Oh, that one failed too. Can you open
But
that?
yeah,
Does that also
I'm
have
not.
private stuff?
No, it doesn't. But I'm not entirely sure why it failed.
Oh, okay.
It's failed.
Oh, I guess then his private
Oh,
stuff
because of his
is only
configuration.
models. Is that his train models that he hasn't
Oh yeah,
uploaded?
he says something, Steve. He does say you have to change some config somewhere. Update the parts, the
All
following
right.
configs.
Yeah. Oh, this is the same as his 1D one as well. You can see like all those paths there that he has down below the data route and stuff. They're not pointing to the Kaggle data. They're pointing to his offline data. Yeah. But yeah, so
Okay.
I think you would need to take his training notebook and train it offline.
Okay. What all is he
Did
pointing
you
to?
train offline, Steve, or do you have a
Yeah.
version of this which?
No, I train offline.
Oh, so you trained on Colab?
Yeah. Although it takes about 20 minutes to download the data from Google Drive over to the notebook, but once you get the data over, it's all right.
So you use what process again? Like one of the other the links kind of stuff, or
Yeah, G down.
get it onto the down.
Yeah. Although half the time it comes back and says that you've had too many accesses of the data set, and then if that happens, then I have to drop back to just doing like a file copy, which takes ages. I don't
Yeah,
know
this
why.
is stuff that you had pointed me to. I think I need to get back to it and figure out the way you had done it, because last time I was like under the pressure of the competition and then kind of gave up on it. But I think I want to get back and at least get that method working. I think you have this approach where you G down it, and then if it complains, then you copy it over, correct?
Yeah, so I have like a little function that does the G down and then looks for the file, and if the file is not present, then it runs the copy.
Mm-hmm. Need to get that working in my. I know you shared the code. I need to go back and dig through it, and if not, I might ask you more questions. That working because yeah, it's a pain otherwise. So you modified all this to then run Colab.
Yeah.
Cool. Then I have to drop off, so I'll talk to you guys next week. Maybe I'll ping and let you know if I'm in. Maybe traveling if I'm not sure yet.
Yeah, I need to drop off now as well, so
Sounds
I
good.
should be here next week.
We'll talk to you guys next week then.
Yep.
Yeah. Okay,
Yeah.
cool.
You guys, take care. Bye bye.
Yeah. Bye.
Cheers.
Bye.
See you later. Bye.